The universe is vast and mysterious. It stretches far beyond what our eyes can see, encompassing realms and phenomena that challenge our understanding. When we gaze up at the night sky, we are filled with wonder and curiosity. The twinkling stars and the vast expanse above us spark our imagination, yet we are seeing only a tiny fraction of what's out there. The universe is so much more than the stars we can see with the naked eye. The universe is not just what we can see, it's everything. It includes all the galaxies, stars and planets, but also the unseen forces and elements that shape our reality. It's all of space and time, and everything within it. This vast expanse is a tapestry woven with the threads of space-time, stretching across dimensions we are only beginning to understand. This includes all forms of matter and energy, from the smallest particles to the largest cosmic structures. Every form of matter, whether solid, liquid or gas, plays a role in the grand design, as well as the laws of physics that govern it all. These laws are the fundamental principles that dictate how everything in the universe behaves and interacts. We often think of the universe as being made of atoms, the tiny building blocks of matter that we learned about in school. These atoms combine in countless ways to form the diverse materials we encounter daily. The tiny building blocks of matter that we learned about in school, they are the foundation of everything we see and touch. It's true that atoms are essential components of our world. They form the elements and compounds that make up all physical objects. They make up everything we see and interact with on Earth, from the air we breathe to the ground we walk on. Every object, every breath, every step is a testament to the presence of atoms. From the air we breathe to the ground we walk on, atoms are the invisible architects of our everyday experiences. However, atoms are only a small part of the bigger picture. Beyond the atomic scale lies a universe filled with mysteries and wonders that defy our current understanding. Recent scientific discoveries have revealed that the universe is far more complex than we once thought. Advanced telescopes and experiments have uncovered phenomena that challenge our previous notions. The truth is, the vast majority of the universe is not made of atoms at all. Instead, it is composed of mysterious substances that we are only beginning to understand. It's made of something else entirely: dark matter and dark energy. These enigmatic components make up most of the universe's mass and energy, yet they remain largely invisible and elusive to our instruments. Atoms are fascinating structures. They consist of a nucleus made up of protons and neutrons orbited by even tinier particles called electrons. The different arrangements of these subatomic particles give rise to the incredible diversity of elements we find in the universe, from the lightest element, hydrogen, to heavier elements like iron and gold. The familiar matter we interact with every day, from the chair you're sitting on to the device you're reading this on, is all made of atoms. This type of matter is called baryonic matter. While atoms are the building blocks of everything we can see and touch, they make up a surprisingly small portion of the universe's total mass and energy. In fact, baryonic matter accounts for only about 4% of the universe. The remaining 96% is composed of something entirely different, something mysterious and unknown: dark matter and dark energy. Baryonic matter, the stuff made of atoms, is what we can see and interact with directly. It's the matter that forms stars, planets, galaxies, and all the other celestial objects that we can observe with telescopes. However, even within this 4% of the universe that is baryonic matter, a large portion doesn't exist as intact atoms. Extreme temperatures, pressures, and gravitational forces in many parts of the universe can rip atoms apart, leaving their constituents in a different state. To understand why intact atoms are relatively rare in the universe, we need to look at the extreme environments that exist beyond our planet. Stars, the giant balls of burning gas that light up the night sky, are a prime example of where atoms are not found in their typical form. The intense heat and pressure within a star's core strip atoms of their electrons, creating a sea of charged particles called plasma. Plasma is often referred to as the fourth state of matter, along with solid, liquid, and gas, and it behaves very differently from ordinary matter. In a plasma, electrons are no longer bound to individual atoms, allowing them to flow freely and conduct electricity. The Sun, our own star, is a giant ball of plasma. Its core reaches temperatures of millions of degrees, hot enough to fuse hydrogen atoms into helium, releasing enormous amounts of energy in the process. Section 5. Neutron stars and supernovae, extreme environments. Stars are cosmic factories forging heavier elements from lighter ones through nuclear fusion in their cores. When massive stars die, they explode as supernovae, scattering these newly created elements into space. These explosions also leave behind incredibly dense remnants called neutron stars. In a neutron star, the gravitational forces are so strong that they crush protons and electrons together, forming neutrons. A neutron star is essentially a giant atomic nucleus composed almost entirely of neutrons. These extreme environments demonstrate that atoms, while durable, are not indestructible. Under the right conditions, they can be torn apart and transformed into something else entirely. Section 6. Black holes where atoms cease to exist. Black holes represent the ultimate extreme environment, where even the very fabric of space-time is warped beyond recognition. These cosmic monsters are formed when massive stars collapse at the end of their lives, compressing their mass into an infinitely small point called a singularity. The gravitational pull of a black hole is so intense that nothing, not even light, can escape its grasp. Within a black hole's event horizon, the point of no return, atoms themselves are torn apart. The singularity at the center of a black hole is thought to be a point of infinite density, where the laws of physics as we know them break down. Section 7. Unveiling the invisible dark matter. In this chapter, we delve into one of the most enigmatic components of our universe. While the bizarre properties of stars and black holes might seem like the most intriguing mysteries of the universe, they are only part of the story. These celestial bodies, as fascinating as they are, represent just a fraction of the cosmic puzzle. The vast majority of the universe's mass is not in the form of stars or planets, or even black holes. In fact, what we can see, with our eyes and telescopes, is just the tip of the cosmic iceberg. It's in the form of something we can't see, dark matter. This mysterious substance makes up about 27% of the universe, yet it remains invisible to us. Dark matter doesn't interact with light or other forms of electromagnetic radiation, making it invisible to our telescopes. This means that traditional methods of observation are useless in detecting it. We know it exists because of its gravitational effects on visible matter. The presence of dark matter is inferred through the gravitational pull it exerts on galaxies and galaxy clusters. Galaxies rotate faster than they should based on the amount of visible matter they contain. This discrepancy suggests that there is an unseen mass contributing to the gravitational forces at play. This suggests that there must be some invisible matter providing the extra gravity to hold them together. Without dark matter, galaxies would simply fly apart. This invisible matter is dark matter. It acts as a cosmic glue, binding galaxies and clusters of galaxies together. While we can't see dark matter directly, its gravitational influence is crucial to the structure and evolution of the universe. It plays a key role in the formation of galaxies and the large-scale structure of the cosmos, shaping the universe as we know it. Section 8. The enigmatic force. Dark energy. Dark matter isn't the only invisible force shaping the universe. Observations of distant supernovae have revealed that the universe's expansion is not slowing down as we might expect due to gravity, it's accelerating. This acceleration is thought to be driven by a mysterious force called dark energy. Dark energy is even more enigmatic than dark matter. We know even less about its nature and properties. Current estimates suggest that dark energy makes up roughly 73% of the universe's total mass energy content, while dark matter accounts for another 23%. This leaves only 4% for all the visible matter we see around us: stars, planets, galaxies, and everything in between. Section 9. Atoms. A small piece of the cosmic puzzle. Atoms are essential building blocks of the universe, forming the basis for all the visible matter we see around us. These tiny particles come together in countless combinations to create everything from the air we breathe to the stars in the sky. Without atoms, the universe as we know it would not exist. However, the universe is far more than just atoms. Beyond the visible matter, there lies a vast expanse filled with mysteries and wonders that challenge our understanding. The discovery of dark matter and dark energy has revolutionized our understanding of the cosmos, revealing that the universe is dominated by forces and phenomena we are only beginning to comprehend. These invisible components make up about 95% of the universe, leaving only a small fraction to the atoms and molecules we are familiar with. While atoms are crucial to our existence and the existence of everything we can see and touch, they represent a surprisingly small fraction of the universe's total composition. The periodic table, with its array of elements, showcases the diversity of atomic structures, yet it is just a glimpse into the complexity of the cosmos. The vast majority of the universe is made up of something else entirely, something mysterious and unknown. These unidentified objects and phenomena challenge our scientific boundaries and push us to explore further. As we continue to explore the cosmos, we are constantly reminded of how much more there is to learn. Each mission, each observation, and each experiment brings us closer to understanding the grand tapestry of the universe. The universe is full of surprises, and each new discovery brings us closer to unraveling its deepest secrets. With every breakthrough, we gain a deeper appreciation for the complexity and beauty of the cosmos, reminding us that we are just a small piece of this vast cosmic puzzle.